this video, we're going to look at photoresistors, a type of sensor that measures light. Photoresistors are light-dependent resistors. Their resistance changes with the amount of light that hits the sensor. They're perfect for making light-controlled switches. You can use photoresistors with 5-volt relays to switch on a light bulb when it gets dark, or use them to track daylight in a weather station. Photoresistors come in a variety of different sizes. Here's a small one. Here's a medium-sized one. And here's a large one. Photoresistors have two separate electrodes on the sensing element. The squiggly red line is actually a layer of semiconductive material between the two electrodes. It increases in conductivity when more light hits it. And when conductivity increases, resistance decreases. So the resistance of the photoresistor decreases with increasing light intensity, and vice versa. In the dark, photoresistors have a higher resistance. And in the light, they have a lower resistance. Setting up a photoresistor on the Arduino is pretty easy. But remember that the Arduino can't measure resistance directly. It can only measure voltage. So we have to use a voltage divider to read the photoresistor. Here's a schematic of a voltage divider with two resistors, R1 and R2. The supply voltage is Vin, and the output voltage is Vout. When the resistance of R1 is equal to the resistance of R2, the output voltage is 1/2 of the input voltage. When the resistance of R1 is very high compared to R2, the output voltage is close to 0. When the resistance of R1 is very low compared to R2, the output voltage is close to the input voltage. With the voltage divider connected to the Arduino, the input voltage will be 5 volts. If we replace R1 with a photoresistor, the output voltage changes when the resistance of the photoresistor changes. With no light hitting the photoresistor, resistance is high, so the output voltage is low. When light hits the photoresistor, its resistance drops, and the output voltage increases. We're going to use the analog read function to measure the voltage at the center of the voltage divider. The center of the voltage divider is connected to Arduino pin A0. The resistor connects to ground, and the photoresistor connects to 5 volts. Remember that the analog read function returns a number between 0 and 1023, depending on the voltage detected at the analog pin. The function returns a 0 value when the voltage at the pin is 0, and returns a value of 1023 when the voltage is 5 volts. In this case, the analog read value will get smaller when there is less light hitting the photoresistor. Let's look at a sketch that outputs the photoresistor's raw analog read values to the serial monitor. First, we declare an int variable called photopin, and set it equal to analog pin A0. That's the pin the center of the voltage divider is connected to. In the setup, we initialize the serial monitor, and in the loop, we declare another int variable called light, and set it equal to the analog read of the photopin. Next, we serial print the light variable to the serial monitor, and delay for 100 milliseconds to make it easier to read the output. So this sketch will read the voltage at pin A0, convert it to an integer between 0 and 1023, and output that number to the serial monitor. Let's see what we get. So here's the raw output from the photoresistor. When I cover it with this notebook, the value decreases. When the photoresistor is uncovered, the value increases. Photoresistors are great for making light-controlled switches. So let's build a light-controlled switch that turns on an LED when the light level drops below a certain value. Wire up the circuit like this. Digital pin 7 connects to a current limiting resistor, which then connects to the LED's anode. The cathode of the LED connects to ground over here, which is shared with the voltage divider circuit. In the sketch, we start by declaring a variable for the photo pin and set it equal to analog pin A0. Then we declare a variable for the LED pin and set it equal to digital pin 7. In the setup, we set the pin mode of the LED pin as an output. In the loop, we take an analog read of the photo pin and store the reading in a local variable called light raw. To make the raw ADC values from the photoresistor a bit easier to manage, we use the map function to convert them to numbers between 0 and 10. The mapped values are stored in a new local variable called light. This if-else statement sets a threshold value that defines when the LED will be switched on and off. When the value stored in light is less than 5, the code in this block will get executed. Since we want the LED to turn on when the light drops below the threshold, we digital write the LED pin high. The else statement is executed when light is not less than 5. So in here, we digital write the LED pin low to turn it off. So let's check this out now. The light level is pretty high here, so right now the LED is turned off. But when I cover the photoresistor with the notebook, it turns on. When I take the notebook away, the LED turns off. This is a simple circuit, but it is a functioning light-controlled switch. You can switch out the LED with any other device you want to control. In the next video, we're going to continue our look at sensors and learn how to detect sound with microphones.